Welcome back, future data scientists. In today's video, we are going to build our very first linear regression model. These are all the topics which we will cover in our video. Today, we are taking everything we have learned, Python, NumPy, and Pandas, and putting it to use to build our very first machine learning model. We are diving into linear regression, which is the simplest but one of the most essential prediction tool. Get ready to train a model that can look like and data and tell you the future. Let's get started. So, what is linear regression? Think of it as a method for finding a clear, straight line relation between two different variables. For example, can we predict how much a house will cost just by knowing how big is it? The model's job is to look at all the data you give and find the single best straight line that passes through all those points. This line is what we will use to make all our predictions. The line just goes like this. These all small black dots are our given data, and this is the best fit line in between this. Similarly, this is the best fit line. This is the formula for the linear regression, and these are all the dots, our data, given data. The main goal of our model is simple to predict an outcome based on an input. In the house example, our input is the size of the house and the outcome is the price. To find the best fit line, the model is really searching for two numbers, the slope, which tells us how steep the line is, and the y-intercept, which tells you where the line starts. These two numbers are the key to entire prediction. Our data. Every great model starts with a great data. Our first step is to use our Panda tool skills to load our raw data, usually from a CSV file straight line into a clean data frame. For this project, our data frame needs to be at least two columns, one for the input, like house size, and one for the outcome, like house price. Remember our data cleaning lesson? This data must be organized and cleaned because garbage in equals garbage out. Let's download our data first. Simply open a browser and here you can, let's go with this example only, the house price prediction. Simply search for house price prediction dataset. You can check on any website, but I suggest you Kaggle as there are many different types of dataset present here. So you can select as you wish. So here's the dataset. You can see here in the dataset we have the column price, area, bedrooms, bathrooms, storage. Main road, yeah. The data set is much larger. Just a second. We simply have to download the dataset, click on download and download the zip file. Oh, I have to sign in with my Google account. Okay, it will start the download. Yeah, you can see the download is done. So, as you can see here, here is our dataset, a CSV file. Just open it. I will show you how our dataset look like. Hey, you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 13 different columns present in our dataset and almost 546 rows. And we have price, area, bedroom, bathroom, storage, main road. These are all the data present. So before using this dataset, I will manually create a dataset, a simpler one. I will show you how this model works and how you can create a model from scratch. Then we will practice on this dataset also. Just minimize it. And before going to our coding part, let's move forward. Good news. We don't have to be a maths genius and write hundreds of lines of complex linear algebra code ourselves. We are going to stand on the shoulders of a giant and use a world-famous Python library called sklearn. This library is full of ready-to-use math machine learning models, including linear regression. We simply import it and we immediately have a professional grade model ready to use. It's a massive time saver. And with this, I will also show you how to create the model manually. This is the most exciting part, training the model. We fed our model the house size and the actual price to the model. We tell it, hey model, look at all the data and figure out the relationship. The model then works hard to calculate the perfect slope and intercept that minimize the distance between the lines and all the data points. Once it finds that best line, we say that model is trained and it's ready for action. The training is done and now our model is predictive. This is the ultimate playoff. We can now give the model a brand new house size, a, a house it has never seen before, and ask it to predict the price. It uses the straight line it learns to immediately gives us the best possible estimate. This is the simple, powerful magic of a machine learning prediction. Now I will show you how to create a machine learning model. Before Without wasting any time, let's move. For this, simply we will start our Jupyter notebook. Course. Here I will create a new file and, and rename as house price. Simply house price like that. Now I will show you how to create a machine learning model. I will explain you each step one by one. One thing, before using this dataset, I will show you how the model is trained and how it works by using our manual simple dataset. After understanding all the different steps how to create a model, then we will work with this dataset. So, first we will import pandas as PD and import NumPy as NP. We had already learned about these two libraries. So next, we will use the sklearn library. So from that library, from sklearn dot model, we are importing the linear regression model from the sklearn library. Okay, this is the library, and we are importing from the library. That's why I use from here, from, and then the library name, and this is the function name model. Model. First, before importing that, I will import the selection. Model selection. I will import train test split. This function is used to divide or to make the dataset in different parts for training the model, and one part is used for testing the model. This function used to split the dataset into two different parts, training and further testing. So again, like this, from sklearn dot linear underscore model. So in this, from sklearn library, using the linear models, I am importing import linear regression. This is how we will import our linear regression model. As I said earlier, sklearn is a library in which we have all the kinds of machine learning tools present in it, and it saves our very last time. So I'm showing you how to use sklearn library in our linear regression model. And lastly, we will import from sklearn import net. This is how all the things are done. Simply run that code and just a second. Okay. Just a spelling mistake. Here you can see it runs perfectly. Starting with, I'll show you. In starting, we will prepare our data set, simple data like df, oh sorry, df. I will show you how to use a CSV file as well as how to import our data manually. Uh, if we have to use a CSV file, simply write pd dot read underscore CSV. Using this function, you can you can use the CSV file, and in these brackets, you simply have to put the path of the CSV file underscore CSV like this. But we are not using this time. Firstly, we will use our dataset, manual dataset, then we will use our CSV file. Simply name the data and we will create a dictionary for from this. First is size and here the list. I think these random values are enough. And one more 4,000 like this, comma, and another is price. Price. Simply price. We will use this much. I think is enough. I'm just adding one more zero in all the sizes. And this is so. This is our data set. Firstly, we will use this simple data set. Then we will use our CSV file. So we had created our dataset. Now it's time to convert the dataset into a data frame for use. So use that pd.data frame. And in this, we will use the data as the functions parameter. So this is, you can see it's, this is our dataset. I ran this code and it simply created the data set into a data frame. Moving forward, Now we have to import, or we simply have to make our data sets different columns. So we will use a different variable to use as a name of the column. We will use x as the name for the first column of our data frame. The first column is size. Here you can see yes, the size, and y for data frame price. Price. Okay. Now simply we will split the dataset into test and training part. For this, we will split into 8:2 for the 80% of the data for we will use for the training, and 24% data we will use for the testing our model. For this, we will simply use the test train test split function. For this, we will create variables xtrain, comma, x underscore test. Similarly, y train and y test. And here we will use train test split. And this we will provide parameters like x and y. These both are the columns of our data frame, as we have mentioned here, x as the first column, the size, and the y as the second column, the price. X and y. We have provided these two as the parameters for this function. Then test size. We have to give the how much we data set we will convert for our testing. We will provide 0.2 as the 20% of our data set. We simply have to put the test size here. It will convert the 20% of this data to, or it will separate 20% data for our testing part, and all the remaining data, the 80% data for the training part. So we simply have to provide the test size. We don't have to provide the training size also. And then the random state as 42. So now we will run this. You can see there is no error, as we have converted the data frame columns, or simply make two variables for each four different columns. Now moving forward, we we had prepared our data set. Now we will train the model. Train the model. Now we will train the model. First, we will create a model instance, an object of the model, simply naming it as model only. And we had uses linear regression, and it's a function. Using this, Now we will train our model. For training part, we will use dot fit function simply as we make the instance as the name as the model. So now onwards, we will use not using the linear regression whole, we will use the naming as the model only as model dot fit. We will use the dot fit function for training the data, and for training we had mentioned it the X train and the Y train. For training the model, we will use these two parameters underscore train comma Y underscore train. Using this, we can train our model. Let's check whether it is correct or not. Linear regression not defined. Just a second. Okay, there is an A in between here. It's it's my typing mistake. You can see here the model is trained. The linear regression model is now trained, and we have used the dot fit function for training our dataset. Oh, sorry, training our model. And this is the dataset we have used for training our data. For model, there as we divided the dataset into 80 to 20% ratio, like this, there are five columns. So one column from this size and one row from this price. These are used for the testing part, and all the remaining are used for the training the model. Now let's move forward. The third part is getting our result, get result. So to get our result, simply start with our slope model. Just give me a sec. I will plug my PC to charge. Now where we are, the result part. Okay, as we had already made the instance as the model, so we will use the model only. Model dot coefficient underscore zero. Like this is the model dot, it's not the comma. Here it is. It's the slope. We will name as slope. Simply coefficient to zero, the first element. This function is used to calculate or the slope of the model. Simply print slope, and you can see here this is the slope of our model 9. 0.99, this much. This is the slope of our model. And for the intercept part, we simply enter use model dot intercept model dot intercept underscore and print intercept. Here you can see this is our model's intercept. One thing I will show you, if we change any value here like this, I will make it 9 and 7 and 19. I'm just randomly changing the values and run this and again. You can see the model coefficients, sorry, the model slope is changed. We had changed the value. That's why the model slope is also changed. And if we run the intercept part, it will also change. All this depends on the model only. Now, the last part and the main part, make the prediction. Making the prediction. And for this, we will use new house size. We will use new house size as firstly we have to convert as an array. We have to give as an array form. This is so what we have used. Okay, we will use 1800 as the new house size, and this is our new house size. So okay, just now predict prediction. We will use this model dot predict function. Predict, and we will use this new house size as the n- new parameter for this model, and we will simply print the predict. You can see here the array. This is our new model or the new house price. This is the prediction our model has generated. One second, I will show make it a simple, little easier to understand. So we will start with 1000 to make it the cheapest, 2000 price for this, and 1000, then 1500. I will make it as 2500. I'm just adding or making the price by adding 1000 to each size values. 1000, 3000, and for the 3000 it's 4, and the 4000 it's 5. Okay, I'm simply doing this so that you can predict by yourself how much the 1800 size house price. 1800 is between this 2500 and 2000, 3000. So it's around 2800. Let's check our model. Here you can see the correct value is 2800. So our model is predicting the 100% correct value as I have used this method, or I have simply made the dataset more easier to understand and predict the data by ourselves. And I done this only to check whether the model is working properly or not. So if you can predict your this model's new value, so you can check also the models is working correctly or not. From this, we had learned how to use the sklearn library and how this function works. For this, now I will show you the same thing without using the sklearn library, the manual part, how to use the manually or how to predict the function manually. We will again simply copy this and making two, three, making just the spaces between, and we will use only the pandas and the NumPy library in this. And for the dataset, we will use this dataset only. Copy the dataset and paste here. Simply remove this. This is the dataset, and we simply convert this into the data frame using this. Now, one more thing is simply have to copy this also. We will use, okay, we will use this. Okay, this done. Now, manually, we will start by calculating the mean value. Start by calculating the mean value. We will calculate the mean value by using the dot mean function of the NumPy library. Simply underscore mean x mean equals to np dot mean function, and for the parameters we will use this x as we are finding the mean of the first column of the data set. Then similarly for the second column y mean equals to np dot mean, and for the second column y column simply calculate this, and just for our checking I will print both mean and y underscore mean. You can see here. Okay, I will show you one by one. I will show you, oh, the mean values one by one. For the x mean it's 23,000, and for the y mean you can see it's 33,000. Sorry, 3,300. My mistake. It's 2,300 and it's 3,300. Hi. Now, after calculating the mean, it's time for calculate the slope. calculate slope and intercept. Now we will calculate the slope and intercept of this. First, I will show you the formulas of the calculating the slope and the intercept. For the slope part, the formula is the sum of the total values of the column minus the mean square by dividing the denominator. Wait, I will show you by typing if you are confused. So now for the slope and intercept part, this is the formula for the slope for the numerator, and this is the denominator. The numerator is the sum of the all the elements of xi, the x column, minus the mean, multiply the y column, the sum of the elements of the y column and the mean, and for the denominator, the sum of the x column minus mean whole to its square. This is the formula for the numerator and the denominator. Now for the slope, simply dividing the numerator by the denominator. And for the intercept part, we will use the y mean minus m multiply by the x mean. M is the slope here. Simply, if I write here the formula for slope and intercept images, you can wait a minute. I will show you. This is the main thing. Y equals to mx plus c. Y is the b is the mean. I said it as the c, but here it is written as b. B is the intercept, and mx of the m is the slope. Is the mean, the y value, and the x value is the mean. Here. Simply you have seen that we will run this code, and you can see here. Okay. We have to convert this dataset not in the data frame part. We simply have to convert in the array format. We will run each column one by one. Here you can see the slope, the mean, and the mean of the both the columns. Now here you can see the slope here and the intercept. And for the prediction part, it's the 2,800. Let's check with the model before. Here's the slope 1.0 and the intercept is 1000. Similarly, like that, here's the slope is also 1.0 and intercept is 1000. Same, and the predicted predicted value is 2800. And in our previous model, the predicted value is 2800. Now you can see we have done both the ways. First, we use the sklearn model to import the linear regression model and machine learning model, and then we had used this dataset and we converted the dataset into data frame. Then we used two different variables for both of the columns. We splitted the test and the training part from the dataset. We then train the dataset by loading the dataset or the model, and Using the dot fit function, we had trained the linear regression model. Then we had s- calculated the slope here. It's the 1.0, and then we calculated the intercept here. It's 1000, and in last we had predicted the value using the house size 1800, and we had predicted the house size at 2800. Similarly, then we have used or train or created the model manually without using the scikit-learn library. We simple use the pandas and the NumPy library. Firstly, we used the same data set here only, and then we converted the data set or the each column into the array format. Then we calculated the mean of both the columns or both the arrays. Then we use the function to calculate the manually functions or the formulas to calculate the slope and the intercept. This is the formula for the numerator, then the denominator, and for the slope, simply dividing the numerator by the denominator, and for the intercept, minus subtracting y mean from the slope multiplied by the x mean. Then we separated this value from the y mean value, and it simply return the intercept here, and then we predicted the value using the same data as the 1800 we had used previously. Then we predicted using this function the slope. It's the same function. Y equals to m multiplied by x plus c, the plus b. Sorry, the y equals to y is the prediction, m is the slope, x is the new size here, and b is the intercept. And we predicted, and the value is the same, the 2800. As you can see, the value remains the same. So, in, in conclusion, we can say that both our models work properly, and we had done the same thing. And for using the manual, this is the simple or the data set we have used simply easier. I will show you using this same thing. We simply, oh, just a second, simply commenting the this data set, and we will name as the data, and we will use the house or the CSV file this time, and I will show you how to use the CSV file. Simply copy the path. Okay, simply copying the path and paste it here. One second. Housing. And here's the housing dot CSV. It's the CSV file. Okay. Simply two slashes here and here also. Simply run this code. Sometimes error. The code cannot. Okay. 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 As we can see, now the path is calculated, and we will update. We will update the column names. One is price and one is area. Okay. Simply we will use these two columns only. Size is area and price is price only. I think price only. Okay. We will use these two columns only. Price, run this. All the things are same. We have to change the data set. We have used the pandas function to read the CSV file. Previously we used our manual data. That's why we uses this only. Didn't use the pandas for the reading the file. But now we use the pandas library to read the file. Run this and we simply splitted our data set. First, we convert or give names to two different columns of our data set, the area and the price as the X and Y. Then we splitted the data set into two parts, the test and the train part. Now we trained our model. Our model is trained. Now for the slope, you can see this is the slope here. And for the test part, simply we run the intercept part. Here's the intercept. And for the house price prediction, I used 1,800 only. And entering, this is the price. According to this data set, just a second. One, two, yeah. According to this data set, price for the house of 1,800 area, the house price will be this much. Now I think you seen all the function methods, or you have learned how to train our model, how to create a model. We had seen all the things that how our model work on the manual data, manually created data, or the CSV file data. We simply have to change the data according to our needs. Then these we splitted our test and train data set. We train our model. We calculated the slope, intercept, and finally we predicted the house value. This is the simple way how to calculate or how to predict the model or how to use the model for the prediction. And also we seen the that same model without using sklearn. We had calculated the mean, then calculated the intercept and the slope using formulas, mathematical formulas, and predicted the value. So now moving forward to our presentation again, the formula. To keep things simple, just remember the core mathematics behind all this. The straight line formula you probably learned in the school. Y equals m times x plus b. In order, the y is the predicted price, the x is the new house size we put in, and the m is the slope of the model, the learn, and the b is the y-intercept. That's all the machine learning is at this basic level. Solving for those two crucial numbers m and b, the slope and the intercept. Congratulations, you have successfully learned the fundamental concept to build your very first machine learning model. From understanding the data to training the predictor, you now have the key skill that every data scientist starts with. Linear regression is the powerful first step into the world of prediction. keep learning, keep building, and I can't wait to see what you create next. Thank you. Stop recording.